In information security, we have multiple algorithms in order to provide the security for the system. One such algorithm is Caesar cipher, which is considered as the simplest algorithm used for encryption and decryption. Before entering into the actual topic and algorithm of Caesar cipher, we need to know what is residual set. Residual set is nothing but the set of all possible reminders. This residual set is denoted as 0 to n minus 1, which means if the residual set is set of 5, then it is denoted from 0 to 4. Okay, what does this mean? Do you have any idea? Yeah. Let me take any number. For example, so since the residual set is 5, let me take 5 mod any number. I'll take 6, whatever it may be. You just try on your own. So if it is 5 mod 6, the answer will be 5, right? Because 5 mod 6 gives 5 because 5 is less than 6. Any number less than the mod value is the same value. This comes to the same value as result. Okay. So whatever number you take, for example, if I take 5 mod 10, I get 5. If I take 5 mod 3, I'll be getting 5, which means 3 is dividing 5. So 3 ones are 3. The remainder is 2. So what this gives is, any number you take and divide 5 by any number, the possible reminders you're getting now, that will be in the set 0 to 4. So this will be the possible reminders. Whatever number we take, that will be in this range. The reminders will be in this range. So this is called as a set of all possible reminders of this particular residual set 5. You done? Yeah. So here are some possible examples of how modular arithmetic works. Since I have already told you that 5 mod 10 is nothing but 5, because this 5 is less than 10. This is applicable to any number. Let you take 2 mod 10 is 2, 3 mod 6 is 3. So this is applicable for any such condition. Now 12 mod 10, here 12 is greater than 10. So we'll perform normal division. You divide 12 by 10. If I divide 12 by 10, the quotient is 1 because 10 ones are 10. The remainder is 2. So this is the remainder that I have written here. So this modular symbol is nothing but this denotes the remainder. Now 10 mod 10, this gives obviously 0. So these are some usual cases that we have learnt already. Now what if we have some unusual case of minus 5 mod 10? In such cases, all you have to do is just neglect this negative symbol and perform normal modular function. 5 mod 10 is 5. Just write it over there. And then we have something called as mod 10. Just write it. So now this 5 mod 10 is already 5. I have to consider this negative symbol and just place it here. So minus 5. This can't be negative. Any remainder can't be negative in modular arithmetic. So I have to simply add this with the modular value. So minus 5 plus 10 is plus 5. So the answer for minus 5 mod 10 is plus 5. As simple as that. The next is minus 15 mod 12. The same way as I told earlier, just take the non-negative part, which is 15. 15 mod 12, that gives me something around 3. And now include this negative, and minus 3 plus this mod value will give me 9. So minus 15 mod 12 is 9. The same way minus 92 mod 6, the remainder of 92 mod 6 is 2. After including minus 2 plus 6 is 4. This is all about modular arithmetic. Now let us get into the actual concept of Caesar cipher, encryption and decryption. Now let us enter into the concept of encryption in Caesar cipher. Encryption. So the formula used for encryption in Caesar cipher is C is equal to K plus P mod M, where M is nothing but the mod value, and in English the M value is 26, since we have 26 alphabets in English, and K is nothing but the key. This key ranges from 0 to 25, since the mod value is 26, which is residual set 26 contains 0 to 25. And then P is nothing but the plain text, and C is nothing but the cipher text. So now let us take an example for P is equal to student. Okay, Now I have to convert this plain text into ciphertext. Plain text is something that we say as an understandable format, uh, which is in readable format, that is called as plain text. And ciphertext is something which is very difficult to understand. So this is the encrypted format of the plain text, that is called as the ciphertext. So for encryption, it's better to list down all the alphabets and the numerical positions in order to perform better encryption and decryption. Okay, now I'm just going to convert this plain text into some ciphertext, which is very difficult to understand. So for this, the formula is k plus p mod m. Let me take the k value as 3, and we have already said that m value is 26, and then the plain text pt is given already, that is nothing but student. Now in order to get my ciphertext, I need to perform the series of steps. The first one is p. So student is a plain text. I have to write the numerical equivalence of the student. Numerical equivalence of S is 18, T is 19, U is 20, E is 4, D is 3, E is 4, N is 13, and T is 19. Okay, so I have listed P. I have to add this with the k value. The k value is 3. So 18, 19, 20, 21. This is 23. This is 6. This is 7, 16, 22 again. And now I have to reduce it with the modular value, which is nothing but 26. So 21 mod 26 is 21, 22 mod 26 is 22. Since 21 is less than 26, the answer is 21 itself, as we have discussed earlier. So this becomes 23s, and everything is the same number. Now, corresponding character for 21 is V, and for 22 is W, and for 23 is X, and for 6 is G, and for 7 is H, this is G, and for 16 is Q, and for 22 is W. So this is the ciphertext. Since we have got the ciphertext as V, W, X, G, H, Q, W, yes, encryption is done. Now let us perform decryption in Caesar cipher. The formula for decryption is, it is as simple as that. The formula for encryption was C is equal to k plus p mod m. I need the plain text p from this. What should I do? It's simple. P is equal to, I'll just take the k that side, so c minus k mod m. This is the formula for decrypting. So yeah, it is as simple. Now I'm just writing the numerical positions of each character, because I have to decrypt this value in order to get the original message. So for V it is 21. You just look into the sequence. Okay, for V it is 21, and then for W it is 22, and so on. So it is 23, 6, 7, 16, and 22. Okay, now I have to subtract it with the k value. So here this is the k. I have written the k as 3. Minus 3 is 18, this is 19, this is 20, this is 3, this is 4, this is 13, and this is 19. Okay, again I have to reduce it with mod, which is 26. Since all the numbers present here are less than 26, they will be as it is. Okay, so the value is simply this. Now I have to substitute the corresponding characters for each numerical position. For 18 it is S, for 19 it is T, for 20 it is U, for 3 it is D, ENT, since we've got the original plain text after decrypting. So this is how Caesar cipher works, the encryption and decryption.